Okay, Chapter 10, Determining How Costs Behave, Part 1. Now these are the learning objectives for this chapter, and it's actually, this is where the interesting stuff starts. We'll describe linear cost functions in 3 common ways how they behave, and the importance of causality and estimating cost functions. And then these are going to go into the next PowerPoint. Okay, we'll finish that. But then we get into cost estimation, different methods of estimating cost, and all of this is more interesting now with all of the increases in analytics and the access to data that we have. So eventually this should probably be updated for new methods and new software and all that, but this is a good start. And then finally we end with nonlinear cost functions and problems that you encounter in estimating cost functions. So a cost function, okay, is a mathematical description of how a cost changes with changes in the level of activity relating to that cost. Okay, that's important. So it's a mathematical expression, and managers often estimate cost functions based on 2 assumptions: that variations in the level of a single activity, okay, in other words, whatever the cost driver is, explain the variations in the related total costs. Okay, a single activity, and that's the tricky part, because there are always other variables involved. And the cost behavior is approximated by a linear cost function within the relevant range. And we know that cost functions, we've got different cost curves. So for a nonlinear cost function, total cost versus the level of a single activity related to that cost is a straight line within the relevant range. Now these assumptions are used throughout the book, but most of this, but not all the chapter, because not all cost functions are linear and can be explained by a single activity. And the more we learn, the more we find that out. So from prior chapters, we're familiar with the distinction between variable and fixed costs, and now we're going to introduce mixed cost. So for variable costs, costs don't change in total in relation to some chosen activity or output. Fixed costs do not change in total in relation to some chosen activity. Variable costs change, fixed costs do not change. These are both in total though. Okay, per unit, it's going to be a different story. Variable costs per unit are going to remain constant, where fixed costs per unit will decrease with increases in output, right? And then mixed costs have both fixed and variable components. They're also called semi-variable costs. Now this is a nice chart. This is the linear cost function, y equals a plus bx, where y is the cost that's being predicted, and a is a fixed cost, and b is the variable cost per unit, and x is the cost driver, okay, the independent variable. And throughout the chapter, just so you know, uppercase letters like the X refer to actual observations, and lowercase letters like the Y and the A represent estimates or calculations made using a cost function. So this is our cost function right here. In statistics, we use the same cost function, so let's review differences in terminology. The accounting variable cost is equal to the statistic slope, or the slope coefficient, the amount by which total cost changes when a 1-unit change occurs in level of activity. All right, that would be variable cost. The accounting fixed cost is the intercept, or the constant, the component of the total cost that does not vary with changes in the level of activity. And the accounting mixed cost is a linear cost function, a cost that has both fixed and variable components. Okay, so this is, I don't know if you've made these connections before, but these are good thoughts. And I like this slide. It's in your text, so you'll have to take a look at it, but we've got a graphical representation of linear cost functions. In the first panel are variable costs associated with the use of CPU hours. Okay, so that's just variable cost. And the slope coefficient is the variable cost per hour used. Okay, and it's 50 cents. Hope this might be small, huh? In panel B are the fixed costs associated with the relevant range of 4,000 to 8,000 CPU hours. And here you can see that this is just fixed, like 4 to 8,000, it's going to be $1,000. And in panel C are mixed costs, consisting of $300 per period plus 20 cents per hour. All right, you can take a look at the illustration in the book. They talk about, I think it's Network Solutions, and which one they would choose, when you would choose depending on how many CPU hours you anticipated. Now, this is a good exercise. Let's write a linear cost function for each of the following conditions using y as your estimated cost and x for the activity of the cost driver. So you should pause the presentation right here and write these up really fast yourself and see how you do. Okay, I'm going to pretend you paused and did it and move forward. So for direct material costs would be y equals 1.70x. Okay. For total cost of $1,000 a month, it's y equals 1,000. Fixed fee of $80 a day and $2 per mile, y equals 80. That's your intercept plus $2 x times the number of miles. That's your independent variable. And finally, for $1,000 maintenance monthly and $12 per day, y equals 1,000. That's your fixed cost plus 12x. Okay, so make sure this is all good and in your head. Now, before a discussion of issues relating to estimating cost functions, it's important to review the 3 criteria we learned about in Chapter 2 used to classify a cost as fixed or variable. And the criteria are, first of all, the choice of the cost object, that different objects may result in different classifications of the same cost, and the time horizon. The longer the period, the more likely the cost will be variable. Isn't that something? It might look fixed in a short run. And the relevant range that the behavior is predictable only within this band of activity. Okay, and these are real criteria. This isn't, something out of a textbook. Managers use cost estimation to measure a relationship based on data from past costs and the related level of an activity. And managers are interested in estimating past cost functions primarily because they can help them make more accurate cost predictions or forecasts of future costs. I had a job like this once, and it was really great. It was a lot of fun. So think about that. When you're thinking about jobs to do and things like that. Now, the most important issue in estimating a cost function is determining whether a cause and effect relationship exists between the level of an activity and the costs related to it. Without a cause and effect relationship, managers will be less confident about their ability to estimate or predict the cost. And remember from Chapter 2 that when a cause and effect relationship exists between a change in the level of activity and a change in the level of total cost, we call this activity measure a cost driver. Okay, that's what drives it. And it's tricky to always see that cause and effect relationship. I've been surprised more than once. A cause and effect relationship might result because of a physical relationship between the level of activity and the costs, a contract, or knowledge of operations. And only a cause and effect relationship, not a correlation, establishes an economically plausible relationship between the level of an activity and a cost. Managers must be careful not to interpret a high correlation between two variables to mean that either variable causes the other. It's a really common mistake. Economic plausibility is critical because it gives analysts and managers confidence that the estimated relationship will appear repeatedly in other sets of data. Okay? And identifying cost drivers also gives managers insights into ways to reduce the cost and reduce costs and the confidence that reducing the quantity of identifying cost drivers also gives managers insights into ways to reduce costs and the confidence that reducing the quantity of the cost drivers will lead to a decrease in cost. Now, cost drivers in the decision-making process to correctly identify cost drivers in order to make decisions, managers should always use a long time horizon. A cost may be fixed in the short run, during which time they have no driver, but they are usually variable and have a cost driver in the long run. And managers should follow the 5-step decision-making process back from Chapter 1, where you identify the problem and its uncertainties, obtain information, make predictions about the future, make decisions by choosing between alternatives, and then implement the decision and evaluate. Okay, in the next presentation, we'll talk about different cost estimation techniques.